5-minute jumpstart your dreams now.
Okay, hi, thanks for this opportunity. So Astra Optics Limited is a startup that's revolutionizing nanoscale 3D printing. So Astra Optics is a spin-off from the Chinese University of Hong Kong. We are One of our co-founders is Professor Shichi Chen. All the technology is founded from his lab. So it's based on over 10 years of research, and our technology is protected with over 3 US patents, which are already granted. And our technology was published in the prestigious Science magazine in 2019 as well as 2022. So compared with other 3D nanofabrication and 3D printing technologies, we have big advantages in 4 areas. We are 100 times faster. Our resolution or precision is 10 times better. Our fabrication cost is only a fraction of is 10% or 10 times lower. And we are able to fabricate directly with 20 plus materials. So all these are critical bottlenecks that are preventing scientific breakthrough as well as industrial applications. In terms of industrial applications, this will unlock rapid prototyping as well as mass production or batch production for optical devices that are used in smartphones, LiDAR, as well as AR and VR. This technology also enables scientific breakthroughs in healthcare drug delivery devices, such as micro and nano robots. And we are able to print structures which have never been possible to print before. Next slide, please. So yeah, we have a strong track record of publications in the Science magazine with 3 patents, and a previous generation technology from our group was also awarded the R&D 100, which is like the Oscars of Innovation Award in 2018. Next slide, please. So here's some highlights of our unique capabilities. So this shows we can print some nano devices or nano wires, which are 10 times smaller than anything that's been ever done before. And this allows us to create some 3D structures which are just not possible, and it could lead to many breakthroughs. For example, we can make invisible cloaks, which have only been theoretically predicted so far. Next slide, please. Another example of an application is a very small optical storage device that can store terabytes of data at the tip of a finger. It can be used in sensors, wearable devices. Next slide, please. One more example is for semiconductors. Microelectrodes can be made with a lot of different metals with high conductivity. Next slide, please. This is an example of an industrial application. Diffractive optical elements are basically small, flat lenses that are used in cell phones, LiDAR, AR, and VR increasingly. And we can fabricate this at a very low cost and with a very low lead time, enabling new products and new designs to come to market much easier than compared to traditional methods. Next slide, please. So just talking about optical devices like diffractive optical elements, the market is growing. It's going to be 16 billion US dollars in the next few years. And this is just one example of a market. So there are going to be more markets like this, which can be addressed by our technology. Next slide, please. In terms of competition, there are other 3D printing companies such as Nanoscribe, which are already established. However, they suffer from big drawbacks of low speed and high cost of printing, as well as limited resolution. We are much better in all of these 4 areas, including material variety. So most of the other printing technologies cannot print a variety of metals. They're typically limited to polymers, but our technology promises to print many different types of materials at a fraction of the cost with a very high resolution and very high speed. Next slide, please. Our go-to-market plan consists of first entering the scientific research market and providing our powerful technology platform to top scientists to really play with it and print something which we haven't been able to do, and enable some discoveries. At the same time, we are working with industries to provide 3D printing as a service and really democratize mass production.
Thank you so much. May we now open the floor to the judges for questions? Thank you.
I have two questions. This is Alice. The first question is, your technology can be used in different applications. What would be your first customer or first target industry that you go to? The second one is, what is your IP portfolio development strategy and protection plan? Thank you.
Okay, so for the first question, we are going to focus on optical devices, namely diffractive optical elements, and we are targeting suppliers of cell phone companies that make these optical devices. We're actually already doing a proof of concept study with one such company here in Hong Kong. And there is a clear requirement for this fast method for prototyping as well as batch production in that industry. Your second question about IP protection, we have already licensed technology from the Chinese University of Hong Kong, and we are already working on some next generation technologies that will take our product even further ahead. I hope that answers your question.
Is there any key milestone that you need to achieve before go to commercialization?
We just have to provide a customized solution to each application. For example, for diffractive optical elements, we have to demonstrate that we can print a high quality structure to them. So we are already working on that.
Okay, thank you.
I got further questions regarding your business model. So you got 3D printing technologies, of course, it's nano printing. So if a customer or a client would like to use your service, how would they gonna engage you? I mean, how would you provide your service to them? I mean, how would you provide your technology service, or you will draw the design for them as well? I just want to know your business model. I mean, if someone engaged you. Thank you.
So it's going to be more like contract manufacturing. They give us the design or they tell us the requirement, and their challenges are typically going to be, the current technology they use is very slow and it's very expensive to print. So we would just help them print what they want at a fraction of the cost, which allows them to enter the market with whatever device they're doing. For scientific applications also, we can provide a similar service if they want to print some structures which they're not able to do with existing technology.
A quick question. What is the biggest limitation of a technology if you want to commercialize?
So if we sell our machines, they're a bit expensive. They're around $800,000 US. So that's the only limitation I see, is the high upfront cost. But if we provide a 3D printing as a service, then that makes it much cheaper.